Inline fan or centrifugal duct fan, which one should you install? The first answer is a correction. These labels do not describe opposite categories. Inline tells you how a fan connects to the duct. Centrifugal tells you how its impeller moves the air. A fan can be both inline and centrifugal. So replace the label contest with three real architectures. A tube axial fan moves air mainly along the shaft axis. A mixed flow fan sends air through an intermediate axial and radial path. A centrifugal wheel turns the flow outward, while a housing or internal guide path redirects it toward the duct connection. Any of these may be packaged for an inline installation. Now build the actual route. Start at the intake grill, then add duct length, reducers, elbows, dampers, filters, silencers, coils, louvers and the outlet. Every component consumes pressure. In many turbulent duct systems, resistance rises approximately with airflow squared. Double the flow and the pressure demand can rise toward 4 times, not because the fan changed, but because the system did. The real airflow appears where the fan curve intersects the system curve. A free air maximum is the point near zero external resistance. It is not the airflow you automatically receive after adding a filter in several bends. Load the filter and the system curve moves upward. At the same fan speed, the operating point usually shifts toward less airflow. This is why diameter, watts, or a single maximum CFM number cannot select a duct fan. Next, compare the packages. A straight-through axial or mixed-flow inline fan can fit directly between round duct sections. It is often attractive where the route is compact, side clearance is limited and the required pressure lies comfortably inside the certified curve. Mixed-flow geometry may provide a useful balance of pressure capability and a straight-through form, but the curve, not the word mixed, proves the duty. An inline centrifugal design can also use straight inlet and outlet connections, even though the wheel redirects flow inside. Other centrifugal arrangements use a scroll housing and a side or rectangular discharge. These packages may be useful when the route has higher resistance, but there is no universal pressure advantage for every size and speed. Compare certified curves at the same airflow, density, speed, and test configuration. Installation can erase a good catalog selection. An elbow immediately at a fan inlet can create non-uniform velocity or swirl. A poor transition can load only part of the wheel. A discharge elbow can prevent pressure recovery and add system effect. Follow the exact manufacturer's straight duct, transition and clearance instructions. If the layout cannot provide them, include the added system effect loss instead of pretending the catalog curve is unchanged. Now test 2 operating points, not 1. Point A is clean filter design flow. Point B includes the loaded filter allowance and the intended control position. Check that the fan remains inside its permitted speed, power, current and stable operating range at both points. If speed control is planned, confirm the motor and controller, minimum command, control signal and protection. A speed controller cannot remove duct resistance, it only moves the fan curve. Noise needs the same boundary discipline. A compact inline unit is not automatically quiet, and a centrifugal unit is not automatically loud. Aerodynamic turbulence, blade passing tones, motor sound, duct breakout, grill velocity, nearby elbows, vibration isolation and the mounting surface all matter. Compare sound data under the same test basis, then inspect octave band or tonal requirements when noise is critical. Service and safety can decide the winner. Can the motor or cartridge be removed without dismantling the sealing? Is there access to the controller, filter, and fasteners? Can the duct support the fan's weight, or does it need independent hangers? Verify temperature, humidity, condensate, outdoor exposure, grease, corrosive or hazardous contaminants, electrical listing, fire and smoke requirements. A general ventilation fan must not be assumed suitable for a kitchen grease duct or hazardous atmosphere. Use this 6-step selection. First, define airflow and pressure. Second, draw every resistance component. Third, choose candidate wheel and package types. Fourth, verify both clean and loaded operating points on certified curves. Fifth, check sound, space, mounting, electrical control and service access. Sixth, commission the installed system by measuring airflow or pressure, input power, and sound. For short, relatively open round duct routes, a compact axial or mixed flow inline package may be the cleanest answer. For higher resistance routes, demanding filtration or a geometry that favors a centrifugal package, an inline or housed centrifugal fan may be stronger. The correct choice is not inline versus centrifugal. It is the fan curve, package, and installation that meet the same real system. For a curve-based comparison, send Longwell the required airflow, static or total pressure, duct sketch, filter and fitting list, voltage and control, sound target, environment, and service envelope.